In this lecture, I want to talk about the const modifier and how we use it with pointers. We've learned about const in previous lectures. It just means you can't change the value of a variable, but what does it mean when we apply it to a pointer? So when we use the const modifier in a variable or an array, it tells the compiler that the contents of the variable array will not be changed by the program. Right? We can also remember the alternative was to create define statements by the preprocessor, but const is usually a more efficient, better way to do it. With pointers, we have to consider two things when using the const modifier. Are we actually saying that the pointer cannot be changed, or are we saying the value that the pointer points to cannot be changed? Right? Because remember, a pointer contains a value of an address, and we may not want to change that address ever, or we may not want to change the value that the pointer is pointing to. In either case, we have to be specific in our syntax. So you can use the const keyword when you declare a pointer to indicate that the value pointed to must not be changed. The way that you provide this, and again, so the pointer is a value, as a value has an address. What it's pointing to is the value of that address. If you want to have that not change, you would do something like this. You would say, when you declare the pointer, you would put the asterisk in the constant modifier before the type. So you would say constant, whatever the type of your pointer is, asterisk pointer. So this is actually defining a pointer to a constant. We're not going to be able to change 999L. So we declared that the value pointed to by the p-value to be constant. The compiler will check for any statements that attempt to modify the value pointed to by the p-value. And if there's anybody that does in the program, it's going to throw an error. So this is the syntax. Again, to know what you want to notice here is the constant is the first word. And it's before the type. So that's saying that the value pointing to cannot change. So if you try to do something like this on p-value, you try assigning a value to what's pointing to, because you see the indirection operator there, that means we're assigning a value to what we're pointing to. If we try to do that, it's going to give an error because we can't change that value. We can't change 999L to 888L. So now what about pointers to constants? And in the previous declaration, we created the pointer that the pointer is pointing to cannot change, but we can still change the actual value of the variable that we declared. Right? So we would still be able to change long value. We just can't change star p-value. But long value is defined, it's not defined as a constant, it's just defined as long value. So we can still modify the value integer pointer because it didn't have constant applied. We only applied constant to the pointer. So we can say value equals 777L. The value pointed to has changed, but you did not use the pointer to make the change. The pointer itself is also not a constant. The pointer, remember, it contains an address. We didn't declare the pointer to be a constant. We declared the pointer, what the pointer is pointing to be constant. So we can still change that as well. So if we declared a new variable called number, we can say p-value equals the address of that number. That's perfectly fine because we're changing the address of the value of the pointer. We're not changing the value of what the pointer was pointing to. So understand this distinction. Either changing the value of the pointer, which is just an address, or changing what the pointer is pointing to. If you don't want to change what the pointer is pointing to, const has to be that first keyword in the declaration of the pointer itself. So again, in this example, we're going to change the address stored in p-value to point to a number. We still cannot use the pointer to change the value that is stored because that was declared as, we can't change that value. You can change the address stored in the pointer as much as you like, just like we did. Using the pointer to change the value pointed to is not allowed even after you have changed the address stored in the pointer. So even though we just changed it to long number, the pointer still had constant as the keyword. So we can't change the value to no matter what the pointer is pointing to. What about not allowing the address of the pointer to change? The value that's in the pointer. So you also may want to ensure that the address stored in the pointer cannot be changed. You can do this by using the constant keyword in the declaration of the pointer the same way, but it's slightly different. Instead of having const as the first keyword, you put it after the data type and after the asterisk. This is saying that the pointer itself cannot change its value. If you put it before the int, you're saying the value pointed to by the pointer cannot change. So when you do this, it ensures that the pointer always points to the same thing. The address will never change. The compiler will check that you not inadvertently attempt to change the pointer elsewhere in your code. You can't change this address. So if you tried to say pcount equals and item, you would get an error because that can only ever point to the count address. It's all about where you place the constant keyword if you want to change, if you do not want to allow the pointer to the pointer to change, or if you do not allow the address of the pointer to change. Constant as the first keyword doesn't allow the value that the pointer is pointing to be changed. If you put the constant after the data type and the star, that's saying the pointer address can't change. So that's a lot to take, and that's very confusing, so study what I just said. Understand that syntax. It's very important. And it's very tricky. It can be easily make that mistake, so understand the difference. You can still change the value that pcount points to using pcount, just like we could in the previous one, because pcount is even though we can't assign it a new address, we can still change the value that's pointing to. So we can dereference it and change it that way. We can say star pcount equals 345. That's fine. References the value stored in count through the pointer and changes the value to 345. You can create a constant pointer that points to a value that is also a constant. So you could do something like this, constant int star constant p item. And that's saying that the pointer itself, what the value is pointing to is constant, and the pointer itself is a constant. So p item is a constant pointer to a constant, so everything is fixed. You cannot change the address stored in p item, and you cannot use p item to modify what it points to. However, you could still change the item. Item is not a constant, so you could change item. You can change the value directly. If you wanted to make sure nothing was changed, you'd have to actually create the item int variable as a constant as well. And then that would say it's never going to ever change. But remember the difference here between constant pointers and constant values that the pointer is pointing to.